Okay, this is rule number 2 and number 7. Differentiation rule number 2 and number 7. You could also call it a shortcut called the power rule. Um, and the purpose of this is for finding the derivative of any basic power function. Okay, f of x equals x to the fifth power. It's a shortcut for finding the derivative of this at x or at a, okay, depending on what you want the input value to be. And if you want to find the derivative of x to the fifth power using the definition of the derivative, you could try that if you wish. Okay, so you could use either formula, okay, but I think this might be a little easier. So limit as h approaches 0 of f of x plus h minus f of x all over h. And then you could evaluate this limit, and then in the end, what you will end up with is 5x to the fourth power. And then I'm going to give you some other examples, and then I want you to try to see if you could come up with a pattern for this rule, for this shortcut. If f of x happens to be x to the fourth power, then the f prime of x would be 4 times the x to the third power. Let me use a different color for the next one. If f of x happens to be x to the sixth power, then the f prime of x would just be 6 times the x to the fifth power. Okay, I think you're getting a pattern. Okay, so let's try a few more here. Let's write a few more until you're convinced, or you could skip ahead. If f of x is equal to x to the third power, then f prime of x would just be 3x to the second power. Okay, maybe I should stop writing f. Okay, or maybe I should choose a different letter. Like that matters. Okay, g of x is equal to x to the 10th power. You could probably guess what g prime of x would be. In this case, you guessed it right. It will be 10 times the x to the 9th power. So how do we generalize this rule, this shortcut? Okay, so if you have to find the derivative of x raised to the nth power, okay, this is what we call the power rule. Okay, so the shortcut looks like the pattern is to move the exponent for the derivative. To find the derivative, move that exponent and make it your coefficient for the derivative. And then x doesn't disappear, but in turn, your exponent now becomes 1 less in degree. Okay, so you could represent that by writing n minus 1 right there. Okay, so the derivative of x to the nth power could be written as n times the x raised to the n minus 1 power. So this is the power rule. On my next video, I'll use the binomial theorem to give you a proof of that, okay, if you're interested. If not, you could skip ahead, you could come back to that video at another time.